So when we look at the tangent function, a simple way to think of it is slope. So tangent is slope. So we can look at it as y over x. So if I take a look at the unit circle here, we can look at it as the ratio of the slope of that line, which is going to be the y position, this green line, over the x position, or in this case, because it's tangent to the circle, that x position is 1. And this is how the tangent ratio actually gets its name. It's actually from the line that is tangent to the circle. So this line here is tangent to the circle, and it generates the tangent function. And in the unit circle, the tangent function is actually the length of this piece here. The length of that line, or how high it reaches up that line, represents the tangent ratio, and it also gives us a length in the unit circle. So our ratio of this rise over run, or y over x, is going to be defined by how far it reaches up that line, or where it touches point P on that line. So what's this graph going to look like? So we want to know what the graph looks like. So the graph looks like this here down below. And we're going to take a look at how we generate that graph. So we want to look at what's happening as we rotate from 0 degrees. So from standard position of 0 radians or 0 degrees. And as we rotate to 90 degrees or pi over 2, what's happening to the tangent ratio or the slope? So if we think of just slope, as I increase the angle, I'm going to reach higher and higher up that line, and the slope is going to get bigger and bigger all the way till we hit 90 degrees. And when we hit 90 degrees, we're going to end up with the line here is going to be parallel to our tangent line, and they're never going to touch. So we can go infinitely long along that line, and we will never touch the tangent line. So we have an undefined value. We could also think of it as the rise and run. So if we think of the rise of that line, and the run is going to be, well, there is no run, so we're dividing by 0, so we have an undefined value. So what does that look like on the graph? If I think of the graph then, on the graph, if I start at 0 radians, okay, so this point here represents 0 radians, and as I increase the angle, the slope value increases, and as we approach 90 degrees, it's just going to increase to infinity. Okay, so we have that section of the graph is generated by that, and the point on this line here is going to be pi over 2, which I've indicated down here. That is there's an asymptote. So as we approach 90 degrees, it gets higher and higher, and we actually have an undefined slope at pi over 2. So we can also look at it in terms of what's happening as we go into quadrant 4. So just getting rid of this here. As we rotate into quadrant 4, do this in a different color. As I rotate this way, my slope line is going to reach lower and lower down that line. The tangent ratio is going to now be negative. So there's my tan ratio. It's now going to be in a negative position. It's going to go all the way, get longer and longer until we hit negative 90 degrees, where the two lines are parallel. So at pi over 2 or 90 degrees, we again have an undefined slope because it becomes infinitely large. If we think of in terms of the slope, that we have a rise and a run of 0, so we're dividing by 0, so again it's undefined. There's two different ways we can kind of frame that. So what does that look like on the function? Well, on the function, I'm going to start at 0, and if I go into quadrant 4, it's going to go in this direction. Okay, so it's going to go, oops, this is my little red line here, so it's going to go in this direction, so I'm going to get more and more negative slope, and as we approach negative 90 degrees, it's going to reach infinitely down the that line, and it's going to be a slope being more and more negative in the infinite values. Okay, so that the graph then approaches that negative 90 degrees or negative pi over 2 and becomes an asymptote there. So that section of the graph, that represents kind of one period. So one period represents just one halfway around the circle, because as we rotate around and we go into quadrants, I'm just going to draw this in here. So we go into quadrant 2, the slope here is going to be the same slope as we had in quadrant 4. And as we go into quadrant 3, the slope in quadrant 3 is going to be the same as what we're getting in quadrant 1. So they are symmetrical across 180 degrees. So that slope then is going to repeat itself as I go past 90 degrees. It's just going to go back into negative slope and then come back from negative infinity. So here, imagine that slope line here is negative, very large negative values, and as we approach 180 degrees, we're going back to a zero slope. So that's what's happening here. We have an infinitely large negative slope value, and it goes to 0 at pi. So there's our pi value here. And as we go through quadrant 4, it just mimics what's happening in quadrant 1. So we start with 0 slope here, and as we rotate to 270 degrees, we have more and more positive slope, which is being mirrored in quadrant 1. So then we start with 0 and it becomes infinitely large as we hit 270 degrees, or 3 pi over 2. So this is 3 pi over 2. So this is what the function looks like. It's a repeating function. It has a period of 180 degrees, or pi.